literally you have a data super intelligence that understands this better than anybody else, then why would you need somebody who understands this? Because you're going to understand it less well than any agentic system. So this is useless. Welcome to Agentic Data episode 5. Hello, Robert.
Hello, Joseph. Glad to be here, as always.
Yeah, we've been getting some good feedback about the fact that we're talking about interesting topics. So thank you all. Thank you so much for giving us your kind feedback. I think that really gets us going and that helps us be motivated about having this podcast. So without further ado, let's move on to some spicy takes. No filler material here. Let's dive into this topic here. There used to be this cliche of data is the new oil, and I think, Robert, when we entered the workforce in, say, the early 2010s, I think we probably drank this Kool-Aid to a bit in terms of, hey, data could enable better data analytics and better inference and better predictive modeling and so forth. There were a slew of companies that came out during that period, like Data Robot, Data IQ, purportedly taking the same type of Netflix challenge-esque predictive modeling to enterprise and then making things amazing. And I think after a few years in that hype cycle, you and I quickly got disillusioned with the promise of data, and we became incredibly jaded. And then now I think we're starting to have a little bit of hope in terms of, okay, I think this time is different. I think that is the intention of this cliche being true for a little bit in the past and now being true again. And there has been a period of this depression that the whole industry had. How do you think about this? How do you think about this cliche?
I mean, it's kind of weird because I feel like I'm like you, Joseph, and I totally believed it when we started. So back when we were building machine learning models, of course, the data was really crude. So it was like kind of taking crude oil and putting it into a combustion engine. But it worked, right? Like we made money. And then I feel like something happened over the last maybe 10 years or maybe last 5 years where we started obsessing over, like, I don't know, trying to build better refineries or whatever the modern data stack was. And then something happened and I felt like we just got distance from data actually living up to the promise of it being oil. But now, of course, yeah, like I want to put oil everywhere, right? Like it feels
we're
like
driving cars, but now we have jets.
Yeah, now we have something like that. Something like that. But what are your thoughts here?
Yeah, I think so. I think things got way overblown in terms of the data scientist becoming or being the hottest new profession of the decade, and predictive machine learning modeling being able to solve any type of business problem. I think things got way overblown. And in some sense, it was overblown, but in some sense, it was justified. It's kind of like now, where AI is overblown to some degree, but in some sense, it is still early days and it's not overblown enough. But I think fundamentally the different situation at hand now is the fact that AI is able to understand, or it seems to process language in a very profound way that hasn't happened before. And because language is the glue that holds together reasoning and holds together processes in our brains that could translate into automating more parts of the work that were not able to be automated before. I think that is the profound thing that has happened. And this allowed AI to go from the realm of pretty much augmented statistics into combining both numerical statistics and language-based statistics, because after all, even language itself is operating under a very, very high dimensional vector space as vectors. So I think the new language model architecture unifies the structured data-based ML and AI, and also more unstructured AI and ML, and we have a unified architecture to put it together.
Yeah. So I know, Joseph, you had this term like activation of data, which kind of harkens to some ETL stuff from back in the day.
Right.
But
reverse ETL stuff.
Yeah, reverse ETL stuff. Yeah. Right. I think just for our listeners, can you give an overview of like how much this can all tendril out into the organization? Because I think it's easy for people to see AI and data and think, okay, text to SQL, and then that, like, what else do? You answer questions with the LLM, but beyond that, of course, there's a lot more that we've talked about being possible. What are some ways? I mean, maybe first, even what is data activation in your view, and then where does it?
In our view, data activation happens. Data activation is being refined and redefined now because of a few forces that are in effect. I think one is the fact that data analytics and data science and machine learning as disciplines are finally mature enough where we know certain aspects of it, where it fails, where it's good, etc., the limitations, the pros and cons. So that has happened. And in parallel, a lot of the software underlying data analytics and data science have materialized and are plateauing, meaning we know what OLAP databases are, data warehouses, query engines, so on and so forth. We know the transformation layer. We know the metrics and semantic layers. We know how BI is supposed to be shaped. We know the languages that we should be using and the packages, SQL and Python. MATLAB and R, they both died, sadly, but everything consolidated around SQL and Python. So that happened in parallel. And then finally, I think because AI is a unifying architecture that combines both structured and unstructured data analytics, data science, and machine learning, the unification of all these forces enable a consolidation of all data work in an organization. And I think that's what we want to call the activation of data. Before, we took data and we needed a massive amount of structured data to shove it into an XGBoost model and do some decision trees, and then finally predict some recommendations on top of that, and build a classifier that predict something, or build some sort of a regression model that predict forecast outcomes. Let's say that has happened before, and that's not new. But I think what we could do today is not only do that type of structured forecasting of things, structured predictions, but we could actually take that data and then use that for observability, for data science and analytics, for structured machine learning, and also use this data to power AI models, like large language model based models, and then deploy this large language model custom inside your organization. And so that unification of all those layers of that cake, so to speak, I think we want to call this data activation. And before, you had to write SQL, you had to write Python, you had to build a lot of custom code to truly activate your data. But I think with the invention of large language models, you could activate all your data and really get use of this data using plain English. And English becomes your natural interface in activating that data. So it's really giving the folks who are mining for insights, let's say, better tools to mine for those insights. And previously, only folks who were technical enough to know SQL and Python were able to mine for insights. But now anybody can, I think. And that's the allure of agentic analytics. That's the high level overview. I think we haven't communicated effectively on why this is so profound, but at least at a high level, the consolidation of a few forces allowed this to happen.
Yeah, it's interesting because it feels like it feels like there it certainly feels like there's been some sort of paradigm shift, right? But the most that I can it feels like the most obvious thing that you can say is that okay, well now people have access to English as a means of accessing analytics information, but there's also it feels like that's a huge understatement of what AI could be. Like the leverage that you could get from AI in this, like it's not like activation is suddenly possible simply because we can talk to the thing, right? There's something else that's happened. It almost feels like the full. I don't have a clear idea of this clearly, but it feels like the full vision of this is like the AI, like AI's LLMs can act as this sort of interstitial glue that fills in gaps where there was too much friction for us to be able to activate data before. I don't have any like concrete examples of where that statement could be backed up, but I mean, what do you think? It certainly
I think
feels
there
like
is something specific we could say about this, which is if you think of, we invented this concept of data programs, right? That's an abstract way to understand all of data analytics, data science, machine learning, and AI engineering, which basically, and data programs are just abstract objects that take data, transform the data, and then finally get to a data artifact as the final output. And this is a way to consolidate everything in data science and analytics into one paradigm so we can understand this better. And before, data programs had to rely on deterministic but highly rigid code-based systems where you had to write SQL and Python and the instructions in a very rigid way. But LLMs allow you and allow the builder to write the instructions in a fuzzy way, and you could write things in a more verbally intuitive way, and the system will figure out how to stitch those two things together, the inputs and the outputs together, by having a language understanding of what you actually mean here. So what you mean by the interstitial glue is precisely this, which is the English is a pretty robust language. Any human language is pretty robust in terms of it's not high fidelity like code in the sense of it's sacrificing precision for the robustness. You could kind of try to understand what you are saying, even if the grammar is wrong and even if you're using slightly incorrect words and so forth. I'm still able to understand the gist of what you're saying, and that was not possible through high precision programming languages. But now we could have error bars around the precision around the language itself, and I think that unlocks a lot of value. And in one sense, the language of the GUI was an attempt to make things more robust, so that there are some error bars around things that you built with the GUI. But almost definitionally, language is so much better and so much more robust, just because it evolved through millennia of human evolution to produce this semantic space, this semantic language space that is very robust against all sorts of disruptions. And okay, and to add one more thing, I think it always feels trivial to describe what has happened that enables a bunch of very profound use cases. Why did mobile let Uber exist? Okay, you have a computer in your pocket, and then you have GPS, so you can finally call a cab. Yay! Like fucking awesome. That completely trivializes the type of profound platform shift that has happened just because now everybody could have this computer in your pocket with that is with you everywhere. That obviously extremely trivializes that platform shift. I think language models, like having English as a native way to instruct computers, and also the English having or human languages having a lot of robustness and error bars, is such an understated way of communicating all the profound things that are going to happen. So I think that mobile example kind of makes sense to me.
Yeah, I think in the last week I recall reading someone tweeting about this, but there was a quote from someone who had been talking about the mobile platform shift back when it first happened, and the person was making a prediction saying, it was basically like a mobile naysayer. He was saying, "Why do you really need a computer? Like you're
oh yes,
how are you ever? You're never so far from your computer. Like, what is the incremental value here?"
Yeah. That's kind of like saying, why do you? I think in the beginning of the PC revolution, somebody said that you're not going to need any more than 128 kilobytes of RAM. Like, why would you need any more than 128 kilobytes of RAM? I think it's very, very similar to that. It's like, why would you have a phone? Why do you have an iPad if you have a phone? It's just this complete misunderstanding of the slight changes that could have a very profound and big effect on human usage of technology.
No, absolutely. So, Joseph, we had a long discussion of this, of course, offline, but this has motivated a shift in our marketing messaging. Yeah.
That's
do you want to talk a little bit about that?
I think last time we talked about agentic software, the fact that you and I are building agentic software at Oxygen Intelligence, and Oxy is the agentic data analytics platform in some sense. But I think recently we've been realizing that the full extent, the full vision of what we want to be is we want to encapsulate this feeling, this concept of activating data in any organization. You have a lot of enterprise data. Not only do you have structured data in your data warehouses, but you have documents and videos and audio, and you also have structured data in your data warehouses and databases and OLTP systems and everything. You have all kinds of data. And I think previously, concepts were streamlined into different buckets like data analytics, product analytics, experimentation, causal inference, and so on and so forth. Predictive models are different from causal inference models, and there were general segmentations in how folks adopted software, precisely I think because the GUI actually limits the adoption of the tool, because GUI is so limited. So that actually forces the enterprise marketing category to be narrower and not broader, just because of the limitation of the technology. I think AI enables one to consolidate the marketing category into one. I think like OpenAI and Claude have the opportunity to become become gateway for anything that you do on a computer, for example. It is truly a platform. It is truly like an operating system where you start there and you end there on everything that you want to do. I think there's something similar in the enterprise software space, wherein all the things that you used to do inside software could be replaced with agentic software. And namely, you could be just talking to AI systems all the time to do everything that you want to do: data analytics, data science, even observability and security, machine learning, and even fine tuning and building your own AI models. I think this very naturally should be part of one giant platform. And so this is sort of the antithesis to the modern data stack movement, I think. So, okay, so cool. You have modern data stack movement, which is really about putting things on the cloud, and you have interoperating pieces. And then sort of the next movement after that, that is just a byproduct, an action against the modern data stack, is really about the composable data stack. I talked about this a long time ago. But I think beyond the composable data stack, which we are a big proponent of, we are open source and we are very, very much composable. I think there is this notion of combining many different marketing categories into a compound system that lets you utilize AI to do everything that has to do with activating enterprise data in all dimensions that interoperate all together with AI at its core. So I think that's what we mean by activation of data, and then also agentic data intelligence, just because you are putting intelligence on top of all your enterprise data. And if we were to be visionary for a second, I think we are building towards data superintelligence, and data superintelligence is a super intelligent system that is just better than any human at any data task in an enterprise setting.
Yeah, and I can't help but wonder how far this goes, in that, I feel like the modern data stack movement pushed everyone to become a bit of an architect, and that kind of became the persona by which everyone defined it. Like even like transformations, DBT coined analytics engineer, right? Like everyone focused very, very heavily on the operational side of procuring the data, organizing the data, getting it ready for consumption, as opposed to, like, it always felt weird to me that it didn't start top down from the objective or the artifacts that you're trying to create and then trickle into. But it feels like there's some sort of parallelism here. Like if you're going to break down some of the barriers here and not worry so much about the way things that, like, data has been moved and data has been processed in the past, and focus more on, like, I have data science and data analytics, but the lines can be a little bit more blurred. I can kind of combine them together. Then of course, like, there's a lot more fluidity that can serve as momentum from the top down to change how all the stuff happens on the architectural side. You know what I mean? Like,
yes, and not only that, I think there's a collapsing of the talent stack. So if the tools collapse into
people have
a
to
more
collapse.
unified tool, then the organizational structure also collapses and the talent collapses. So data analysts, data scientists, machine learning engineers, these are all overbloated terminology from the past. And we are seeing this in our own company, and also startups that are building today. You don't really need a PM. You don't need a separate product designer. You don't need a front-end engineer anymore. Front-end engineers and back-end engineers are merging to become a full stack developer, and product designers are becoming also product managers as well. And so I think there is a confluence of many things, but yes. So talent stack collapse, functions are going to collapse, tools are going to collapse, and architectures are going to collapse within a company. And so there's this very big gravitational force that is caused by AI to change all aspects of how a company operates.
Yeah, like, it's, oh man, this is so interesting. Like, people aren't rate limited by their ability to, by like the technicals, like their ability to deal with the technical stack that underpins the work that they actually do. And so then you just end up with this collapse, but also like maybe an inversion of the standard practice of data teams. You don't think from architecture first. You think more from what you're trying to do.
Yeah, what are you trying to do? I think solutions first rather than architecture first.
Which, for what it's worth, I also like pushed for really hard back when we were doing hyperquery, if you remember.
That is true, but it is true. Everybody
I think it
that.
wasn't possible. Yeah.
Everybody knows that that's the better thing to do.
That's right.
It's just that if the thing that you're selling is very highly rigid against traditional marketing categories of how software is consumed, then you can't just
That's right.
Gaslight yourself into
That's right.
thinking that we could be solutions first if you're selling software.
Yeah, that's right. That's right. That was the fallacy.
Yes, that's a fallacy. But if we're moving towards agentic software, I think it's finally possible that even the people running the data teams could be very solutions oriented rather than architecture oriented. If the limiting factor was understanding the complexities of like an OLAP query engine, how to set it up, then of course it mattered to have people who understood that. But I guess economics is about scarcity, and if that is not scarce anymore, literally you have a data super intelligence that understands this better than anybody else, then why would you need somebody who understands this? Because you're going to understand it less well than any agentic system. So this is useless. So you should actually have people who are able to take tools and build solutions on top of these tools, which should be actually how organizations should be run, which generally means that people with clarity of thinking and good taste will win in this new paradigm, which is how it should be. And it shouldn't be rate limited by, we're kind of destroying ourselves here, but it shouldn't be rate limited by people with, math and physics degrees from Harvard and MIT.
Man.
Yeah. It's a relic of the past. Although, like, these degrees helped us think a lot better. That the rigor of thinking we could at that precise age in our teens and early 20s, just completely unmatched.
Yeah, that's right. So not completely worthless. I wonder what will happen.
We're not completely worthless. Good.
All right, what should we talk about next, Jeff?
You want to talk about the language translation problem?
Yeah, we can do that. Yeah, you had this analogy of you had some abstractions that you'd constructed over agentic analytics, such that the main objective appears to be this sort of English into abstract representation of the instructions into SQL and Python. But you want to talk a little bit more about precisely what you mean. I mean, you're the mathematician, so you have the definitions in your head.
I think everybody already understands this, and this is how things are done in a lot of domains of computer science. And so this is not something novel, but I think what we're realizing is that it is very helpful for us to really redefine the basic assumptions in agentic analytics and agentic data intelligence, because nobody is actually defining them, and people are just very, very mimetic, and we think that nobody really knows what they're doing, and they're just screaming out semantic layer and hoping everything will stick. And so I think the core of agentic analytics is really about using English as a way to instruct a computer to do data tasks, right? Okay, I don't even think that people have articulated this concept. Okay. So, there you have it. So English to data instructions to get the computer to perform data tasks, in which the data tasks constitute a single chain in the data program that eventually gets built into a data artifact. So that's what you want to do. And of course, you're using English, but English is a language that could do a lot of different things. It could reflect emotions. It could communicate emotions. It could communicate stories and principles and things like that. The space of English as instructions, and in particular, English as data instructions, is a very small, compact set inside the grander space of English, the semantic English space. So let's just understand that for a second. So what we're doing in creating agentic analytic systems is we're taking English inside the data instruction space and then mapping it and then translating that into something that a machine could understand, namely SQL and Python, which are the two languages of data. So there's that perspective. So it's a language translation problem from the data instruction space in English to the SQL and Python space, which both are English, I guess. Both are English, but these are programming language English. So we're going from this one space to the other. Of course, now we're going from one domain to another domain, so you need a map here. And I think the way to think about this is that any English data instruction should have some abstract representation that is pretty robust against small changes or different permutations of the language that begets the same type of semantic representation. Meaning there's so many different ways that I could say something, a data instruction, that are basically the same thing that I want to eventually get out at, right? So like, how do I think about that? So the way that I think about it is the data instructions in English gets translated into an abstract latent representation of that instruction. So this is very similar to if we're trying to understand SQL queries, the way that we think about it in computer science is that you think about an abstract syntax tree of a query, for example, and then try to reason about things in that space. So there is, in a lot of different cases, reasoning about graphs, reasoning about trees, reasoning about some abstract computer science object or mathematical object. It's a lot easier than thinking about a more unstructured object like free floating, freestanding English or something like that. Even for SQL, people had to invent the relational algebra to try to think about what it means to have instructions. So that ties us back to the latent semantic determinism or the latent deterministic scaffolding research that we're doing, which is really about how do we have a latent representation of certain instructions and also artifacts in our tool to get to the final output. So I think this is sort of tautologically true that this has to happen, but it is still really helpful to lay it out like this, because without the taxonomies and the vocabulary to even describe what we're doing, you're never going to solve the problem. And I've literally never heard of anybody set up this problem in a more rigorous way. All I've heard was if you have a data catalog and you put metadata and then you put LMs, and then you win. That's literally what I've heard.
That's right. Especially as I think we've talked about this before, but of course, from the translational point, one of the vectors, one of the variables, or maybe the output metrics that we want to play with is entropy, right? We sometimes you want to have high entropy, or temperature, I guess is the LM term, but you want to have high entropy. Sometimes you need very, very low entropy. Sometimes you need idempotence of the process that's happening, even when the LM is involved. Sometimes you don't. Sometimes you need deep research. Sometimes you need, I don't know, they're properties of the system that are very difficult to reason around unless you start with some sort of fundamental theoretical definitions. Otherwise,
that's right,
you're just reasoning about English, which is super, it's kind of what LMs do, but it's messy.
Yeah, English has the great property that is robust against errors in the transmission process. It's kind of like an error correcting code that I'm sending from myself to you, has a lot of error correction built in, but it's extremely low fidelity. So we need a higher fidelity way to precisely describe what is happening. And I guess being rigorous around these definitions and the vocabulary to describe each thing is quite helpful in actually inventing this entire system. And once it's invented, then folks could be more lazy and more broad about how you describe and how you use the system.
Yeah. So, Joseph, you also mentioned right before you started talking about the language translation definition of analytics, of agentic analytics, you mentioned the semantic layer. It's kind of like a should we kill it?
Okay, why don't you go ahead, Robert? I've been talking for a while.
You want me to do it? Okay.
Go ahead.
So I guess on two sides of this, so we've had a lot of themes here. For a bit, Joseph was talking about how we could be a little bit more solutions focused. I think the semantic layer is a very clear example of where you have a system that is not inherently architecturally focused, but it is also one of the closest things to consumers that data people have ever created. It's intended to just allow for self-service to happen by simply clicking in and selecting measures and dimensions in combination with time granularities and things like that. Joseph and I are obviously the components, the underlying components are still pertinent to any system that you might want to create within the agentic analytics world. But I think there's this very strong tension here where semantic layers feel like they violate Pareto optimality. And I've been thinking about this a lot, but
could you take a step back and explain the concept of trying to span the vector space of questions and answers and how to do that before we get into Pareto optimality?
Yeah, my brain is going crazy. So maybe even first, let's go into that. So if you want to create a agentic analytics system, the first thing you have to decide is, what does robust mean? And I think for me, or what is your objective function, right? How do you even measure whether the thing is successful or not? And I think one definition that you can adopt is, how well does it cover the span of questions that are being asked, or the tasks that are being asked of the system? And then from that perspective, what you would want to do, as with any, say, machine learning problem or any problem in life really, is figure out the optimal algorithm such that you converge to maximizing your metric against that objective function as quickly as possible, right? TLDR, you need to choose a measurement, a metric, and then do everything that you can to maximize against that metric. And I think
as fast as possible.
As fast as possible. And I think the semantic layer is a great example of where you basically do this as slowly as possible, where what you do is you focus, rather than focusing on say mapping the space of questions to answers, what you do is you try to cover the space of all questions and answers very, 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 very systematically by defining, here are all the measures against all the columns, against all the tables that we have defined in our data warehouse. Here are all the dimensions that are defined as columns in our data warehouse. Here are all the joins that define the connections between all of these tables. And now we have but if we just precisely define all of these different objects perfectly within YAML or within JavaScript or whatever, I guess we'll have a system.
It's the slowest. Yeah. It's the slowest non-trivial way to map the space, in the sense of the slowest is actually you just mapping it by like just throwing darts.
Sure, fine,
just having single.
Okay, so you get some
queries. So you're
get
having cubes,
Cartesian
right?
products of the
So you're
right?
basically
so like
cubes.
There's a
so yeah. So like you have this really high dimensional space, and then you're trying to cover it by uniformly putting cubes everywhere. And of course, that is one way to do it. But okay, so how do we do it? How do we do it non-trivially?
And of course, just as a final comment here, like of course people I think intuit that you shouldn't do this, which is why like they start with the measures that are important. But like the point is that like the world is, so for those who don't know, Pareto, let me just define like Pareto law, Pareto rule. But the idea behind the Pareto law is that 80% of the value comes from 20% of the effort, right? So this is colloquially applied to things like, okay, when you're working, you should just try to like work smarter, not harder, right? But of course, this is a pattern that exists that defines a distribution that applies to many systems that exist in the real world. One of which I would imagine is the distribution of questions that are being asked within an organization. There's certain questions or topics or whatever the granularity is that you want to build this distribution on. There's certain objects that capture most of the questions that are being asked within an organization. And the natural thing to do is you should figure out how to answer those questions with any system that you construct first, and then slowly move down the ranks until you have sufficient coverage that you're satisfied.
But in a generalizable way, right?
In a generalizable
way, in the sense of like you're not actually answering that question, but you're answering a family of related questions.
Exactly.
Around that question.
Exactly. And so there's this ontology that I think emerges. Joseph, we obviously talked about this, but like I think there's an ontology that emerges from usage patterns, and I don't precisely know exactly how this looks, and this is something that we're still researching. But you can imagine like dashboards and reports and things like that. They can act as first-class citizens in defining what this Pareto optimal world looks like, right? Like, of course, like there's a few dashboards already that probably capture. I mean, we talked about the whole trashboard phenomenon before. There's a few dashboards that likely capture all like 90% of the traffic of amongst all dashboards. And I imagine looking at those dashboards, dissecting them, and figuring out why they're important can define itself a very natural hierarchy of components and semantic objects that you should probably focus on first before you start trying to boil the ocean, building an entire semantic layer. Now, this is a spicy take. I don't want to die on this hill, but at the same time, I think almost mathematically, almost provably, if you're trying to do as little work as possible to cover the space of things that you want covered, the best way to do it is not through a semantic layer.
In the traditional BI sense.
Traditional BI sense.
The traditional BI semantic layer. Okay, yeah. Let me ask you a counter. But
sure.
Can't you argue that the precise reason why you want to keep track of metrics in the first place is because these metrics are already Pareto optimal things that you want to keep track of? For example, revenue and all variants of revenue and cost and profits are the precise things that you want to automate away. So in some sense, you are actually using some sort of Pareto optimal way to cover the space, albeit using cubes. So it's conditional on cubes covering the space.
That's right.
The BI semantic layer is in some sense Pareto optimal in coverage, but you're saying something a little different, which is don't use cubes. Maybe there are better ways to use more high dimensional objects to cover this space of all questions without having to specify cubes. And could you give at least one specific example? Because it sounds like, sorcery if we just don't say any specific examples.
I mean, one specific thing that we've been doing with actually a few of our customers already has been automating reporting pipelines, right, Joseph? And I think the report as a primitive is something that is not deterministically constructible through semantic layer objects alone. You have to have some sort of pipelining system. I mean, we use our workflow system, but you need some sort of higher level abstraction if you want to create a deterministic pipeline that generates the same report.
So are you saying that in a data program, in the BI world, the data program always outputs basically a measure, like crossed with the dimension, and that's what you get? But you're saying that we need to have higher order data artifact primitives in the data program. In particular, you're saying perhaps a report is such an abstraction that is a higher order primitive, then those things could be used to actually map the space in some sense. Is that what you're saying?
Correct. That's exactly correct. I mean, even to a lesser extent, even dashboards, I think, fall under that categorization as well. It's like a higher order object that traditionally is built manually from the components that are exposed from the semantic layer. They themselves are not hardened in a sufficiently reproducible, automatable, LM interactable way.
But let me push back on that a bit.
Sure.
What about, and I'm devil's advocating because I'm obviously on your side.
No, it's fine.
What about if you have Claude and then you could MCP into Tableau dashboards and you could actually utilize that somehow using AI? Why is that different from a more de novo approach that you are implying?
I mean, I think there's a number of, it depends on what you're trying to accomplish, I suppose. If you're trying to take the Tableau dashboard and say, build a deterministic report that's repeatable, just to use that example that I gave before, obviously, there's no guardrails, there's no systems in place such that you can with some certainty say that it's going to output the same synthesis from 1 month to the next. So that already is like an example of where this could fail. But I think more generally, what's weird about, it really just, I guess, depends on what you're trying to accomplish. Like if you're trying to synthesize the dashboard into something, then there's obviously shortcomings there. If you're trying to take the queries, say, from the Tableau dashboard, maybe, or like you're trying to API into Tableau and like get the raw data out and then do something with it, I think the same determinism problem is posed again. You can only build insofar as you have an infrastructure or a framework that sits at the level that you want to automate against. And so doing it at the primitive level is necessarily going to restrict you to being able to interact with things at that primitive level. So for example, in Tableau or in any semantic layer or in any BI tool, you're going to be able to interact with measures and dimensions, but wanting to do anything beyond that, you're not going to be able to reason in any higher order way. No emergence is going to happen.
Is it because dashboards, like say Tableau dashboards, were not built on the back end to allow for the modular consumption of that dashboard to recreate and recombine and to span the question space?
Yeah, and this is exactly why programming languages are fucking great with LLMs, right? Because you have access to every level of abstraction. You could have access to the base components that are used, the base classes that are used. You have access to the higher level classes. You can build in any way that you want. But of course, that also comes with a lot of entropy. And we've talked about this. That's acceptable in software engineering because you just need the thing to work, and there's a million ways that it can work. But for data, there's often just one right answer. So you need a system of both primitives as well as abstractions that sit on top if you want to get to the right answer often.
Is it because Tableau dashboards are not built in an object-oriented way that could be shown to an API call as being object-oriented? Because it is likely that these dashboards are actually built in an object-oriented way underneath their hood, but they're not designed such that when you MCP it or API it returns all of the metadata object-oriented fashion that is conducive for an LLM to use that information. And one of the problems is that you actually start to need BI declarative BI as code in some sense if you want to get that information and you do something with it, which obviously no winning system like Power BI and Tableau are built in the BI as code world because they're precisely BI as GUI. That's literally their abstraction. Is this why?
I mean, yeah, that's that's exactly it, Joseph. I mean, yeah, I feel like if you could I can't stretch my brain far enough to see how Tableau is object oriented anyway. Maybe in like the restricted view of the world, but like I mean, all the object oriented principles like encapsulation and inherit. Like, does Tableau even have inherit? I mean, I guess like you have to start asking like, does the sequel in some way object or like, but it's not right. But
I mean,
now I'm
it
having an
certainly is
aneurysm
probably
because I'm trying to like fit this into my brain.
it's probably built in a way that a dashboard is composed of visualizations, and a visualization.
Sure. Okay. Okay. You're talking from the higher level grammar. Yeah.
That is object oriented, right? Like they probably would have built it like that.
Yeah. Yeah. I think it just doesn't stretch far enough. I think that's just it, right? Like yeah. There's some components that are certainly capture object oriented principles, but that modularity, that reusability that you usually get with object-oriented programming languages, it just doesn't extend far enough into the things that you actually want to be modular.
But as a counter, what if you had access to? We assume that it was built completely object-oriented, and you had complete access to source code of Tableau. Would it be different? I think it is theoretically possible that you take that and then actually reconstruct things. But the issue is that it is hard. It is very hard because it was not built for that consumption and remixing type of use case. And that's where being declarative really helps, because being declarative separates out the runtime and the specification so that you could actually just look at the specification and do what you need to do with that information.
Yeah, that's right. That's exactly correct. Yeah, the declarative nature of our product really, but I think any good system here just allows you to I guess reason around the things that matter more elegantly than ending up getting mired in the details of technical objects.
I guess it is theoretically possible that, say, both Tableau and Power BI, they both decide to refactor their entire system so that it could surface a declarative interface that powers everything. Such a refactoring work will be of an immense magnitude of pain.
Yeah, I'd be really curious to see what would happen if they, like, either of them just were like, okay, we're going to open source our code base or something, and then like what you can do is just vibe code attach against their I don't know it makes no sense.
This is the innovator's dilemma. These tools are making billions of dollars, and people love using these tools, so it's really hard to let's not use the word love. A lot of people use these tools, and a lot of people are forced to use these tools. So I
think a lot of people love Power BI, but I haven't heard that in a while regarding Tableau.
Right. There was a time in which I forgot to mention Power BI in a choice of popular BI dashboards, and I got attacked by hundreds of folks saying that I'm a fucking idiot, and you forgot to mention like literally the number one BI tool in the world, and I was harassed for days.
That was hilarious.
Yeah.
I mean, it's an understandable. I mean, the Microsoft stack is just so closed that if you don't work at a company that just happens to be on Azure and then also happens to be on Power BI and builds everything with Azure notebooks, you just don't get exposed to it. Also, I'm like the products seem compelling, but I'm just not sure if they can keep up with the pace even of the modern data stack.
Yeah. I mean, their attempt is in building Fabric and really pushing for the lakehouse architecture using Spark and so forth. But Microsoft is not really known for being a first mover. It's really about waiting until things happen and then packaging and actually out distributing everybody like Microsoft Teams against Slack.
Yeah, that's right. Cool.
It's interesting times. Okay, so that was your rant on semantic layers and why covering your space of questions with cubes is likely not the most optimal solution. You need a better way, and mapping things out with abstractions like workflows and reports, and actually taking those modular pieces out and then reusing them to map the space is likely a more Pareto optimal solution. Yeah. I
Time will
think
tell. I will prove it over time.
time will tell. I think we didn't even mention why it's helpful to think about agentic analytics as a problem of spanning the space of questions and what spanning actually means. Maybe define the linear algebra term for us.
That's right. Oh, you want me to do it? Why don't you do it, Joseph? This is your...
Is this my wheelhouse?
Yeah.
Yeah, so I mean literally the space of words is literally a vector space because words get tokenized into a very, very high dimensional point in a high dimensional vector space in Rn. And so you could think of all the questions that, say, one may want to ask in an organization about an organization's data as like a cloud of questions floating in space in a very high dimensional space.
Yep.
It has some topology. It has some shape, and we want to be able to try to reconstruct that question space in some sense, and also look at the corresponding answer space, which is also a high dimensional vector space. And then what we mean by spanning the space is there a way to linearly combine certain vectors to make sure all the lines that are constructed using the vectors connect to all the points in the space. It's like one simple way to think about it. And that's a very nice graphical way to think about this agentic analytics problem is spanning. And spanning is just another word for, if I took a linear combination of vectors, like basically multiply it by some scalar and like stretch it by a scalar, and then also add other vectors into it, then how do I form lines that point towards or cross over certain points? And because the underlying mathematics of large language models are based on linear algebra, we could actually graphically try to understand. And that's what we mean by spanning the vector space.
Yeah. And I wonder if there's some sort of, I mean, obviously, like the kind of natural conclusion or the bridge that people will probably jump to is a way to represent questions and answers is perhaps like some semantic space, right? Like embedding space. But once you start doing that, it becomes clear how the dynamics of questions and answers would work. Like suddenly all the rules of like what is a linear combination of a couple questions? But
I see.
I get what you're saying, but I'm now I just want to poke at the rigor.
No, of course there's a linear combination of the questions, but the way that you have to think about it is not in the main space. You could probably project it into that latent space and then try to do some calculations in that latent space. That's why having the latent representation is very important, because of course there is some notion of conjunction, right? Like, and what is this and this? Of course that's a linear combination. Of course that's a linear combination.
That's right.
Makes complete sense. But like, how do you think about it in a more rigorous way? There's probably you map it into a more like abstract representational space in which you could have some things like string additions make sense, because that addition doesn't have to be Euclidean addition. It's some sort of other abstract addition in which in that space is very, very well defined. And if you pull it back to the original Euclidean space, is nonlinear. So maybe it's a kernel operation. This is coming back to me. 15 years ago, I used to do some work on string kernels. You could construct string kernels in which you could define well-defined inner products between strings, and then you could have the notion of an inner product, and therefore you could have a metric. So these things are possible.
Yeah.
And so theoretically, these things are possible, but again, we're trying to make things a little bit more high level and abstract here.
Yeah, I'm just getting sniped. I mean,
so there you go. There's my defense to your sniping.
I could go endlessly down this route. Well, I guess one maybe just like humor me with one last comment. I mean, it feels like, so I guess my qualm was just like, and as an operator, for example, it's not well defined in semantic space, right? Like you don't conjunction isn't just like the addition of two things, but of course, like there's a very specific way that it should be defined within. Like if you do and say, and you add a measure to a or add another dimension to a question. So you say like, okay, the revenue is in a country. I guess there is like a latent space that such that not only is like there enough distance between objects, such as there's like discernment against business concepts, but also the notion of conjunction is well defined in terms of the operations that in terms of whatever, like the non-Euclidean in a product that you're talking about, it like is well defined, and it also maps the numerical properties of that operation nicely to the properties of the framework
Right,
that
right.
is
But
built
but I,
against
I
it.
guess at the very least, the way that you could think about this is if you go from English to latent semantic space and it gets translated into this, let's say, SQL space, then at
Yeah.
least in the SQL space there's a relational algebra. So there is
Right.
conjunction and there is also dimensional
Yeah.
reduction. So you could actually reason it about in set theory in
Yeah.
that way. So
Okay.
you could map it here and then you could actually rigorously start thinking about it.
Yeah.
So
Good
at least
point.
there's that. Like
Yeah.
there is a rigorous way to think about conjunctions and reductions in the relational algebra space, which has to exist because it goes
Yeah,
there.
that's right. That's right. That feels like okay, and that's the correct answer. But it also feels like a cop out. But I get it. I get it.
Yeah,
That makes sense.
specifically, we don't know if that is the correct way to reason about things because, in some sense, the LMs take care of this latent representation for us without us having to manually think about the sigma, like not the sigma, the relational algebras and so forth. So that's a good thing.
Do we ever have
Okay.
to? Sorry. Okay. Last
Yeah.
thing. I promise.
Yeah.
Do you think we'll ever have to discover what this space is? Like, is it always going to be latent? Like, will we have to? I mean, like, it almost feels like we can't quite fine tune our way into this, but there
No,
is
I think
some sort
we could
of
probably discover what this space. I mean, this space actually might be universal. I mean, you know
yeah.
how compression is done using language models, right? You have a like massive, very wide layer, and then you get increasingly constrained, and then you have a very
Right.
very very narrow layer, and then
Right.
that
Right. Right.
narrow
Right.
layer
Right.
contains the compression of like say an image. That's what we're
Right.
doing.
Yeah.
Like
Yeah.
in
Yeah.
some
Yeah.
sense, it's like we're going into a lower dimensional like
Yeah.
abstract representational space, which is like compression, and then
Yeah.
we'll get to look at say the parameters there, and then we'll get to observe what that latent representation actually looks like in some
Yeah.
sense
That'll
later.
be fun.
But
I'm
but
excited.
all we could do is if the results are good, i.e., like
Yeah.
one, like the coverage of the question space is very fast, and then also you have high precision on the answers, and then sufficiently good recall, then with good summary statistics of the overall system, then you kind of making the leap of faith that then the compression happened really well,
Yeah.
and then you look at the
Yeah.
compressed space.
Yeah. And I
So
guess
that's probably how.
that's all that matters in the
Yeah,
end.
there's that experimental design, and there's absolutely no way to analytically try to understand what that compression looks like. It's just like you experimentally look into it, which is like the annoying thing about deep learning is that. But I mean, it's already amazing that these systems are working in the first place. So we should just
Just be
take it for
grateful.
what it is. You just be grateful for like this new type of electricity that we have discovered. Okay, last thing for you. Last thing is we read some interesting research in the past week about persona vectors and
oh god, yeah, right.
using algorithms to improve itself, and you had some qualms about robustness testing and leakage and whether this violates any rigor in the pure statistical sense. I think just as a backdrop, I think there are crazy things happening in which during pre-training folks are coming up with all sorts of crazy abstractions like vaccines and data poisoning and personas and like these really intuitive and also very helpful abstractions in understanding how a model gets trained. So that's the backdrop. It does seem like these are good abstractions for us to understand, to try to reason why things are happening in a certain way. But okay, walk us through your problems with persona vectors.
I mean, I don't have very serious problems. I think it mostly comes down to me just not understanding what's happening. But I don't think anybody does. But that aside, the high level take from this blog post from Anthropic was they devised these persona vectors, which were basically just like patterns that they saw within within the LLM that manifested when the LLM took on certain characteristics, so certain traits, like it was evil or something, and then like whenever across all the like instances where it was evil, it demonstrates some pattern of activity against a few specific nodes in the neural net. I mean that already is, it's super interesting, right? But the first question that I had was, how did they get the training data for this? Because like that's the real problem to me. Like you can, and it seems, as far as I can tell, it seems like what they did was use the LLM to synthetically generate training data. And so then there's this weird question to me, as someone who's trained in traditional machine learning, where I'm like, okay, you just need to make sure there's no leakage. And all the traditional systems for, say, like generating training data and then injecting it back into your base model, they were like SMODE, if you remember that, Joseph. Like they were all okay, but they just like reinforced the bias that was already existent in the training data that you started with. Like it was very difficult to come up with novel examples that reflected reality in a way that was relevant to the model. And what's very strange to me is that like LLMs seem to have broken out of the cage in some way, where like I guess it's an accepted pattern to use the LLM to generate training data for things, but I guess apparently also for itself to do things.
Right.
And it's just like my brain breaks. It's like I think I just don't have a good sense of first how LLMs, like what it is that, like in traditional machine learning models, there's like a very clear path from here's how the algorithm works, here's the objective function, and here's how like that leads to some sort of final model that makes predictions for you. In LLMs, that path is very, very strange, right? We don't understand if there's some sort of emergence going on. We don't know why when they get bigger they just do better rather than overfitting, for example, which is something that you brought up, Joseph. This whole thing, like all the alarms in my head, which are certainly wrong because they're from a past that didn't involve LLMs, they just scream like leakage, bias, just like don't do this. But yet this still seems to be the state of the art. And like why, like how is it that an algorithm that produces data to improve itself can do anything beyond what the original algorithm can do? I mean, okay, just I'm speaking very, very broadly, of course, like, but why can't it do more than what the original algorithm can do? Like why can't it break out of bias in that way?
It might be that we talked about degrees of freedom here. It might be that if you add enough degrees of freedom and you actually have a different physical system, you can't apply Newtonian mechanics to quantum mechanics, and deep learning is actually approaching quantum mechanics territory. So you can't even try to reasonably use the notion of variance and bias in the same way that you would do in a traditional statistical system. That might be why. I think it might be a breakage. We went from lower dimensional statistics where everybody screamed that if you have too many dimensions in your model and you didn't have enough sample size, then you're going to completely overfit and you're going to have a lot of bias, and it's a high variance model and you're going to get super messed up. And okay, that happened. And I think the natural extension to that is, okay, let's have Bayesian non-parametrics like Gaussian processes and Dirichlet processes and things like that, which was still like a mathematically elegant extension to like the analytical statistical world. And then an entire break from that is like, okay, I guess deep neural nets are asymptotically, like one layer of it is asymptotically equivalent to a Gaussian process, but that's kind of that's like the bridge to the statistical world. And it has some like nice mathematical asymptotics. Like you could pretty much model any defined function using a Gaussian process. So ergo, you could do the same thing for deep neural nets. Okay, that's awesome. That's sort of our bridge back into the old world. But maybe beyond that, there are no ties, and maybe you have to have some different abstractions to understand this physical system. If you do think that this is like a different physical system, which it might be. I mean, as someone that like study complex systems and rivers and things like that, neural networks are kind of like a new type of river that exists, and you have to have different methods to understand. So maybe you're just so stuck in the Newtonian mechanics world.
Yeah, we've reached some sort of critical point, and there's just different dynamics. It makes
sense.
Yeah,
it turns out that actually all you need is backpropagation, which is kind of crazy to me. Like all you need is basically like the chain rule in calculus, and like everything suddenly magically works. You need some sand to make some transistors. You put some sand and then like you fucking like use chain rule, and then suddenly everything starts, and then enough data, and then suddenly everything makes sense. So yeah, thank you LLM gods that such a thing is working.
Yeah, seriously.
Okay, that was the last question for you.
Cool.
So
good stuff, Joseph. This has been fun.
Yeah. So we'll be wrapping up here, and we'll see you next time on Agentic Data.
Bye, everybody.
Bye.